All right, Mr. Ahmed here for section 1.2 intermediate algebra. Central question for today is how do I solve multi-step equations? So in 1.1 we did easier equations that only required one step. These ones will require multiple steps. Our goal is still the same. We're still looking for the solution by isolating the variable on one side. With the multi-step ones, there is a little bit of a procedure that we want to follow though. So the steps to do it are first to simplify each side of the equation if necessary. The first example of distributing would be if you see a set of parentheses. So it would look something like this, 3 times x plus 2. The parentheses indicate I have to distribute. When we distribute, we multiply what's outside the parentheses to all of the terms inside the parentheses. So I would take 3 times x, which is 3x, and then 3 times 2, which is plus 6. So if I see parentheses, I'm going to have to distribute. The next step would be to combine like terms. Examples of like terms are something like 3x plus 7x plus 8. In this case, 3x and 7x are like terms. I would combine those if they're on the same side. Okay, so if they're both on the left side or both on the right side, I'd put them together. When I combine like terms, I add them. 3x plus 7x is just 10x. So this would be equal to 10x plus 8. So make sure we simplify both sides first. Then we're going to use inverse operations to isolate the variable. Most of the time we'll add and subtract before we multiply and divide, but there are some cases where we will not. So hopping into some example problems. Our first one says 3.5x minus 4 equals 17. So we have to isolate the x. In order to get the x by itself on that left side, is there any parentheses? No, I don't have to distribute. There's no like terms. I cannot combine those. I cannot put a 3.5x together with a 4. Okay, they'd have to both have an x with them, which they do not. So there's nothing for me to simplify. I'm just going to start using my inverse operations to get the x by itself. So add and subtract before we multiply and divide. So I'm going to move my minus 4. The opposite of minus 4 is to plus 4. And I'm going to do that to both sides of the equation. If I do it to the left, I have to do it to the right. The 4's cancel. 3.5x is equal to 21. Now, just like we did the other day, we're down to a one-step equation. To undo the multiply, we will divide both sides by 3.5. Divide 3.5, and we'll have our solution. You may need a calculator for some of these. 21 divided by 3.5 is 6. So feel free to use a calculator if you need to. Number 2, this is one of the tricky ones where we're going to multiply before we add or subtract. And the reason why is the entire side is being divided by 5. Since that entire side is being divided by 5, I'm going to undo the division portion of the problem first by multiplying both sides by 5. Notice again I used parentheses to indicate multiply. I don't want to put an x in there for multiplication. That could get a little bit confusing. The 5's cancel. H plus 6 is equal to 2 times 5. That is 10. Now we're down to a one-stepper. Subtract the 6 from both sides. And H is equal to 4. So make sure you're showing your work in a logical order working down your page. Example 3. Here we go. This one, left side. Definitely see some like terms. I have a negative 2x and a negative 10x. So I need to combine those. I have to simplify first. Negative 2x plus negative 10x is negative 12x. Plus 12 equals 18. I should have put my equal sign here on the line. There we go. Our next step, add and subtract before we multiply and divide. So I'm going to subtract 12 from both sides. Cancels off. Negative 12x is equal to, and we have 18 minus 12, that is 6. Divide both sides by negative 12 now with the one-stepper. And that's a fraction. That's okay. We're going to leave it as such. X is equal to, tricky part, positive divided by a negative is a negative. I'm going to reduce my fraction. 6 over 12 is 1 over 2. That's negative 1/2. If you got negative 0.5, that would be okay. And example 4, the first one where I see some parentheses. So The left side just has a 15. It's going to stay as a 15. Equal signs there. Now this 5 is going to stay. The only thing that's outside the parentheses that's being multiplied is the 4. So I have to multiply it before I add and subtract it. I can't take 5 plus 4 then distribute because only the 4 is being multiplied. Okay? So we'll distribute the 4. So 4 times 2 is 8D. And 4 times negative 3 is negative 12. Notice our 5 was still there. Don't lose track of him when you distribute. All right, 15 equals. Are there any like terms? Yes. 5 plus negative 12 is negative 7 plus 8D. All right, next step. Add our 7 to both sides. And we got 22 is equal to 8D. And then we'll divide both sides by 8. And again, we got a fraction. I'm just going to leave that as 22 over 8. I could also reduce it down to, let's see here, 22 over 8 would reduce to 11 over 4. 2 goes into 22 11 times, 2 goes into 8 4 times. And we found our solution. So, on the back side, this is a spot where you should pause the video, try these two out, and then turn the video back on and see if you got them correct. All right, after our pause break here, hopefully you got some success on numbers 5 and 6. First step, there is a parenthesis, so I have to distribute. So 3x plus 3, our 6 is still there, plus 6 equals negative 9. Now from here, like terms, 3x plus 9. We combined these two. Equals negative 9. Subtract our 9. 3x equals negative 9 minus 9 is negative 18. Divide 3, divide 3. And x is equal to negative 6. All right, last example for the U-tries. Set of parentheses again, so we're going to have to distribute. So I'm going to distribute my negative 4. Negative 4 times 2m is negative 8m. Minus 20 minus 3m equal sign 35. Like terms, combine them, round them up. Negative 8, negative 3 is negative 11m. Minus 20 equals 35. Add our 20. And we got negative 11m is equal to 55. Divide negative 11. Both sides, do it to one, have to do it to the other. And m is equal to negative 5. If you need to use a calculator for that division, feel free. All right, number 7. Here's the skinny on number 7. This problem's pretty tough. I'm going to leave this one blank. If you would like to give it a shot, feel free. If you come in, show me some work shown with the correct answer, that's going to be 5 extra credit points. You need to show me it, though. So number 7 is on you. Little star by it. Bonus. 5 extra credit points. You need to show work, though. There will not be one like that on an exam. And number 8. Since we didn't try number 7, I'm going to help you guys out with number 8. And again, same process with this word problem. We're going to have to pick out the keywords, highlight them, and then set up an equation. So it says, Eric got a new phone a few months ago. He paid $130 for his phone and pays $37 a month for his plan. Currently, he has paid $426. How many months has he had his phone? So we want to figure out how many months he's had it. We know he paid $130 to start. So let's say $130 plus $37 per month. I'm going to call month an M. So plus 37 per month. And he is currently paid $426. So his total payment, he's paid $130 plus 37 per month. That has to equal $426. Now we can solve for M to figure out how many months. So I'll subtract 130. And 426 minus 130. Is $296. $37 per month, $296. And then we'll divide by 37, divide by 37. And I got 8. So that 8 represents that he has had his phone for 8 months. So I'm going to write out my solution and say Eric has had his phone 8 months. And that's all we have for today. Make sure you fill in your summary. What did you do? Well, we solved multi-step equations. How did we do? Do we have questions? Write in your summary so when you come to class, you're prepared and ready to roll. Have a good one.